So first of all, so what we are going to do today, so I'm just going to remind you what was the enrollment process. And then I have some remarks on the class location for the next classes. And then today we will first introduce the modular programming and what does this mean in Python, and what's the relationship to import syntax, and then how you can use the external package, and in other words, why Python is great. So you will learn this today. And then I'm going to show you a very nice toolkit, which is Numpy. And if we get some times left, we'll introduce you to pandas as well, but I think we won't cover it today. And finally, by showing you how Numpy and pandas work together, hopefully you won't need to open Excel or MATLAB or any other similar programs anymore, because you can do everything in Python much more like conveniently. Okay, so let's first of all talk about the enrollment. So what I see in the OLAT, there are 98 enrollment there. When I see into Piazza, it's 65 now. Last night was 62. And then when I see the number of people who uploaded their Colab notebook, I see just 43 people. And that's why I just want to remind you that the enrollment process was to first, so register on QIS. This is for the university. Do this Colab notebook and upload it, and then sign up for Piazza. So I hope I need to see like kind of numbers that are like kind of make sense for both Piazza and the number of people who uploaded their notebook. Okay, so this is first thing. Second, about the class location. So if it depends how many students we have. Look, I think we are more than 40 people for sure. So that's why we need to somehow make the class kind of hybrid. So from next sessions onward, we will have an hybrid class. So people can register and come to the class here. So we have one people here today. So Semir, right? Yeah, Semir is here today, but for the next sessions, you could also register and come. There's just one technical issue here that for the third and fourth sessions on 28th and 1st of November, we need to be in the room Dubai, because the beamer here doesn't work apparently, and people need to fix it, and hopefully it will be fixed by the 5th session, which is 8th of November. Then we can come back to Boston, which is the main classroom. So how you can attend the class? So there is a program in the university that is called My Booking .vvunifrankfurt.de. You need to go there and register with your student ID. And there you should search for data analytics course. So there's no appointment to register, but if there is an appointment to register, you can see that there is a button here. You can just click on register, and then you will be registered there. And then yeah, like I think you get a barcode after that in your email, right? Should I unmute myself? Yeah.
Yes, you get the QR code. You get the QR code at the top of your My Bookings. You just go show, and then you can show it when you come to the class.
Great. So yeah, that's how it works. So
you enter the invitations one by week?
Like 3 days before.
Okay. I think it's important that if the room capacity should be too small, yeah, then we don't want always the quickest students to be here. Yeah, so please make sure, yeah, that if 3 days before the new booking is assigned, that if you have been in the classroom last time, yeah, maybe you wait for other people to book first, yeah, and
Exactly.
if then at the end there is still capacity free, of course, everybody is
Sure. Yeah.
is welcome to come to the classroom.
Yeah. Exactly. But for this, I had. Unfortunately, I don't have it here. I had a poll in Piazza for like to ask students if they want to be in the class or not. So, oh, I think I closed and removed it. Yeah, but basically the thing was that like 1/3 of the students they wanted to stay always online. So hopefully this will work somehow. And yeah, let's see how it will evolve in the next sessions, and then we will probably come back to this point and discuss it more. Okay. So just one more point here. So for the other people who don't attend to the course, to the classroom physically, we will stream the class via Zoom with the same link as we had before. So everything would be the same. Yeah, that's the points on the organization stuff. Now let's start with our class. So I guess if you go there, I already uploaded my Jupyter notebook for today. So for yourself, you can just copy and edit it here for your own browsers if you want to just change things and try things yourself here. But let's go together now. So first, I just want to start with the modular program. And modular programming means the most closest example I found is Lego. So if you have, if you work with Legos, you could say that there are some parts that you can use. So simple parts that you can use for many things. So in programming, you have the same concept here. So for example, you can just define a function or a class and use it in several other applications that you want to have. Okay, so how this works with Python. So we store some part of the code, like this section that you see here. We call it, we save it in a .py file, .py file, and then.
Can you show this, please, how it works?
Yeah, sure. Yeah. So you save these things in a .py file, and then this could be imported later for your applications whenever you want. So for example, this file that you see here, I already uploaded into this section as a file example modules.py. So if you just want to open this file, you can see this is all there. I just saved it as a .py file, and it's in my folders structures here. So what I can do, I can just import the functions inside this file. I will go to this later, but let's first talk what is inside this. So I have one function, square it. So basically for any number that I get, I make to the power of 2. I have another function, which is a square root of a number, which is like the square root of a positive number or a none if it is a negative thing. And then I have a class of stock beta. And for those of you who don't know what is a class, so Python is a object-oriented language. So basically, you can create objects. And the way to create the object is to define a class of objects. So basically, I can create an object of a stock beta for Apple, and I call it Apple beta. Okay, and then I can define many functions or methods inside this class that I can work with this object. So if the object is the beta of Apple stock, I can just do some calculations with some methods there. So for example, I can just adjust the beta for those of you who knows a bit of valuation, if you have like if you calculate a beta for a stock of some companies, you can just adjust it to make it more closer to 1. Okay, so because people say that historically the betas should be reverting to 1. That's why you make it closer to 1 somehow. And then this is like a method to do this for us. So we can just define a stock beta of 1.22, and we call it the apple beta, which is an object here. And this object could be printed. So if you print the object, you can see that, let's say, yeah, you can see that this is an object with some codes that's stored in your memory. And then you can apply these functions to this object that you have. So we have an adjust beta function. So you can just say this apple beta that we have, just do this method on that. And then if you do it, you can see, so you got 1.22. Now, if you adjust it, it will be closer to 1, which is 1.13. Okay, this is how you work with the objects. Okay, now we have this code here, but for example, you want to save it somewhere that you can use it later for another program. So maybe it is like a big file of millions of functions, and you need some of these functions later for another program. So that's why you need to store this file in your PC and then always address to it. So I just run this, you can ignore it for now, but I can come back to it later. So how you can import. So this py file is stored in my input folder, and there is a folder called example modules, and then the file name is example modules.py with capital letters. So what I can do is to you can just tell the Python to go to this folder, example modules, and then with dots you can just go to one folder inside, and then inside that there is like a module called example module with capitals, and then from these big files you can import some functions. For example, you can import the square it function, and you can rename it as well. So you can say import this function with this name that I want, and then this name you can just use this name and use it as a function that you want to work with. So yeah, so this is how it works. There's another way also to do this. You can just say from this folder import this file, and it will import everything there. So if you import this everything here, you already imported the class and other functions. So you can say that by doing this, I already import the class stock beta. So I can just call it example modules dot stock beta 1.3. So it will create an object of beta, and I can work with that later. Or you can just call the functions of it. So example modules dot square it of something. So the thing is, if you import the whole library, you need to put the name of library in front of any function or class. So this is the only difference. Okay. Another thing is if you want to see where's the file of this Python, this py file, you can just always call this, when you import it, you can see example modules and the dot file. This will give you the location that this file is located. If you want to change this file, for example, sometimes you work with some big libraries and there is a problem into one of those codes that you want to resolve. This is the way you can find that module, and then you can just directly go with your PC inside to that file and change whatever you want. Okay. Any questions here?
Can we all try to save something? Because I don't even know whether my computer knows the root, the folder.
Hello.
Yeah, yeah. So,
Yeah, but
so the way I did that, so if you are into this notebook, you can already go to this example modules that I have here. You can just
yeah, but there was nothing when I enter this. There was nothing on data. Or am I wrong?
I think.
Oh,
You
it
see that?
is.
Yeah.
Okay.
Yep. So there was no question?
So this data is basically embedded in your Jupyter notebook.
No, they're separate files
Yeah.
stored somewhere in the PC, and then you can just import them. So this is true for all the other external packages, but I will show you in details now. Just let me reload this. Okay. So let's talk about the standard libraries that exist in Python.
Excuse me, Professor.
Yeah.
I'm sorry, but could you give some more explanations about the class and self-point?
Okay. Yeah. So when you define a class, so I just skipped it because probably you won't need it. You won't define a class very soon. But so what you when you want to have a class, you should start it with an init def. So what this init does is just say whatever input this class has, so all the variables that you will have in the class, you just need to give it to the self, and this self is an object inside this class, and all the functions that you have in this class, they are stored in the self. So if you like, so you initiate the beta that you get in when you start the code, this beta is into the self.beta, and then this self.beta, you can just work with it with other functions. You can just square it. You can just, for any function that you want to have into the class, you need to start with self, because self includes all the variables inside that object. And then you can just self.beta power of 2 and just return this. Okay. So this is like the standard way of defining a class. You start with with an init, and in init you must put everything, all the variables you have in a self version of that, and then you define your functions there.
So basically, the first line, underline init, underline, and then
this is a standard. Yeah, this is a standard. Yeah, it's always the same.
Only beta is basically what you.
Yeah, beta is like the one of the things about a stack beta object. So a stack beta objects can have properties, and one of the properties is beta, and like all the properties of this object should be initiated here. No, just yeah.
And beta is just a variable at this point of time, or is it?
Yeah, it's a variable. It's a property of the stack beta object. This is how we call it.
And if you would like to add the alpha, for example, how would you do that? Just for example,
the alpha, and then you need to initiate it as well. Self alpha equal to alpha. Yeah.
Okay,
But,
thanks.
But just be careful if you do this. So if you put anything into the init, then when you create your object, you need to import it as well. So you need to initiate it with some numbers here. Otherwise, I think you get a problem. So let's see. Yeah. The init is missing another thing, which is alpha. So you need to, you need to make sure that when you create your object, you just pass them to the class. Yeah.
Thanks.
I also posted a link for what classes are and how they work in the chat. So this can be quite helpful if you are still confused by the concept of classes, because this is a concept that's often hard to grasp in the beginning.
Yeah, this is, but as I said, you just need to know what is a class, but you don't need to define your classes or work very often with them. This is usually done by professional programmers, and you just use them usually. But it's important to know that, for example, if you have an object, how you apply a method to that. So for example, you have an object, you just need to dot method. So for example, you have this object. If you want to have the method, you just need to have a dot, the name of that method. That's the important part. There was a question here. You had a
yeah, it was the one with alpha.
Oh, okay. Okay, good. Great. Okay. Any more questions? Cool. So let's talk about the standard libraries. So when you install Python, there are standard libraries that is installed on your PC with installing Python. So some of the important ones are maths. So you can just import maths, and then here is the documentation. The good thing about libraries are that they are all documented very well. So you can see the library of maths, this has this kind of methods that you can use, and this is how you can use all of them. So for example, you can see, yeah, I think I have better examples here. Here. So for example, you can see, for example, number pi is already installed into the maths library. So if you want to work with pi, you can just import the pi. So you can just do calculations with that. Or for example, the function exponential, you can just create the exponentials of a numbers. So you can just search for the so you can see it here. So this is the function that get a number x. So return the e raised to the power of x. So basically, an e is this, and it's based of natural logarithm. This is usually more accurate than this version. So this is like how well documented is this. So you can take a look at the other functions here. If you want to use them, this is like how you will use them. Okay. So another library which is very important is the Sys library, which is a system related issues. So if and one of the most important part of that is the path. So the Python has a path here. So if you print the path of your Python, you can always see lots of directories that are inside your path. So for example, on my current path, there is like the folder Kaggle working, Kaggle lib, Kaggle gym, Kaggle lib, and all these things are there. And then if you want to have, so for example, you have your module somewhere, and if you want to make sure that your module will be imported whenever you import it, so no matter if it is inside your folder or not, you need to append this to your path. Okay, so you can, You can see it here. So I have this Kaggle input example modules. This path, I just append this, and then this will be there into the path. And then whenever I just want to use these example modules, it will be on my path. So I can just import it without any error. The other important library is OS, which is OS related things. So for example, you can get the working directory that you're working now. So for example, for me, it is Kaggle input. So if I just create a file or anything, it will be appear here into the input. You can change the directory to some new directories. So for example, you can say OS change directory to like another directory. So just go to output and then create a file there or read something from there. This is how you can do that. Another thing is a list there. So if you want to, for example, loop through lots of files inside the directory, you need to get the list of files there. And this is the way you can get the list of things. So OS list here gives you the list of files and folders. So here we have just 2 folders. That's why we have 2 folders here. And if you, for example, want to get the size of a file, so you can see I just want to get the size of this file into the input text test.text.txt, which is this actually. This 41 bytes. This is a simple text for test. So you can see that this is 41 bytes shown here. Sometimes you need these things to work with files. And the documentation is here. So you can for sure look at you can look at the other things you can do in this with OS. Everything is well defined here. So I just like the change directory and so on. Okay.
So where do you know which directory they actually look at? You give it the name first.
Yeah, so for this
test,
get size, you
text,
mean?
yeah, input / text is basically.
Exactly, this is the folder. Yeah.
Print.
Another library is IO. So if you want to work with files, so read files that are already there, you need to use IO. Most of the times you don't need to import IO, and this is like already there. You just need to open something without the IO, but I just write it to just make sure everything is the same as before. So you can just open a file that is somewhere. So you can just say, I want to open this TXT file and read it. If you want to have it write something, you should open it as a write. But here we just want to have it as a read. So we open this file with reading, and then we just say this variable is the read of this file. And then I just want to print the text there. Okay. Yeah. So there are this 3-4 libraries are like one of the most important libraries that you use from the Python library itself. But the cool thing is that you have access to external libraries that are created by other peoples. So there is a great community in Python. So they've created lots of libraries for anything you can imagine. And for example, some of the libraries that are used for data science tasks are Numpy, Pandas, Matplotlib, and so on. We will introduce you to Numpy today. And but there are the thing is that they are all very nicely documented. And if you know the basics of how to use Python, you should easily get get to know these libraries and start working with them.
Can you please go back to this printing? Yeah. So import IO is clear. Yeah. Then this with, what is this with? This is an order that is basically telling Python to open.
Yeah,
this.
exactly. I just want to open a file.
Yeah. And you always put with in front of it.
Yeah, you need to address the file. Where's the file located? So this is the address of the file.
Yeah, but usually you would simply say I open and then file. Why is there a with in front of it?
Okay. So this is like a safe way to open a file. So when you open a file with with, so after this with, so when the file is when the compiler is here, the file is already closed and your file is not damaged anymore. That's just to make sure that the file is closing here. So this is so if you work with Python 3, this is the only way, I guess. In Python 2, you could just open it.
And what says as f?
So this is the IO object. We stored it as f, and f has some methods.
Is a name. We gave
yeah,
f.
Exactly. So this is a file, usually f, and then we can apply the read method or write method or read lines and so on.
Okay.
Yeah.
So txt is basically a variable that we
variable.
define, and we said this is the read of f. Yeah?
Exactly.
And f was defined to be the file.
On
the folder.
Exactly. Yeah.
And what is the difference between the read and write methods?
So with write, you can just add things there. So let me. You can open it with a write, or like I would append something, because if you write, it will be deleted everything, and then whatever you write would be there. But with append, you can just append something on top of what is already there, and then you can say f write something. So I just want to do it in a new line. So I do this. It's a read-only file. Problem here is I don't have the permission to. But basically, I can. Should give myself the permission to work with this file. No chance. But on your own PC, you can do that. Basically, you can just open with a W, or I have no chance here. You can just open the file with the writing or appending mode and just write things you want there.
Okay, it's clear. Thank you.
Okay.
And Professor, just one question concerning the sys path append. So does it mean that to create a new document which contains all the codes we created in the path? Okay.
Yeah, you just put it in the past to like assume that you work in the folder X and you created this module.
Okay.
And then you have a new project somewhere else in another folder 10 years later. And then you're just working on that folder. But in order to be able to import the first file, you need to have the path of that file into your system path. Otherwise, if you say import this, it say I don't find it.
Okay, I see. Thank you.
Yeah. Okay. So how you can install external libraries. So the easiest way is to use the Python package indexer, which is a PyOrg website. If you go there, you can see all the packages available. So you can just search for the package that you want. And usually, so for example, we want NumPy today. So this is, for example, one release of NumPy, which is NumPy 1. You can just say pip installs this, you just copy it. And in order to be able to install, you basically need to have a terminal. And in your terminal, you say pip install this. You can just do this. It will be installed on your PC. But if you want to work in Kaggle, for example, you need to do it from here. And then in order to be able to give something to the terminal, you need to have this sign first. And then whatever you write here, it will be a terminal command. So pip install with an exclamation mark in the beginning. It will be a direct command to the terminal. Because we already installed NumPy, that's why it's a requirement already satisfied, so we don't need to install it again. So it's already installed. Sometimes you need to update it to make sure you have the latest. Yeah, apparently it wasn't the latest. Yeah. Okay, so I installed 121.3 and I had before 119.5. So this is things, but you usually don't need to use the CU.
But I also have a question. So I read that if we use Anaconda on our local computers, it is recommended to use Conda environment instead of.
Yeah. So this, like talking about Conda environments, is one of the presentation topics that one of you guys need to present next week. So you will get to know that. Okay. Now let's start with NumPy. So NumPy is a great tool if you want to vectorize your code. So how it does it. So if you work with MATLAB, for example, you can see that all the things are done with kind of matrix solutions, and you need some linear algebra to do the stuff, but it will be at the end a great help for you to make the codes very efficient and do them very fast. So I just want to show you so the most important parts of NumPy today. All the things that we discussed today, they are you can find them in the NumPy documentation, which is in the first source. There is also a nice mini course on GitHub. You can just enter to NumPy, open this as well. And also from the 4th chapter of the book, Python for Finance, Mastering Data-Driven Finance, which is in the, yeah, if you don't have this book, like I will upload some of this the important chapters into the OLED with the password that I will provide you later. So you will be able to have these books after the class. Okay, so first of all, I just want to import NumPy. You can import NumPy as it is, but usually if you import NumPy for any command you want to do, you need to write NumPy dot something. So that's why people just want to make it easier, just import it as NP. So you can write NP dot something, which is easier. So this is the first step. And then in NumPy, there are, we work with arrays. And arrays are the main objects of this of the NumPy, and they could be 1D arrays or 2D or 3D and more. The more than 3Ds, they are called tensor, but you won't work with them now, at least. Yeah, so basically, a 1D array is just basically a list. a 2D is like a kind of two-way list, and then you have two axes here. Axis 0 is a row and axis 1 is a column. And if you have a 3D, you have the third dimensions as axis 2. And so how you can define an array? So there are many ways to do that. So there are some predefined array types. For example, you can have an array of 0 with a shape of 2 into 3. So for example, as you see here, I just, this is basically, yeah. So this is an array of 2 and into 3 of zeros. So all initiated with 0 already. You can have an array called I. So with the I, you have like in the main diagonal, you have 1s and 0 everywhere. So sometimes you need this kind of matrices. You can create a random array. So you can just get 2 by 2 matrix of random numbers. You can have like integer randoms from 1 to 10. So for example, I need an array of 3 to 3 with random integers from 1 to 10. So this is like what you get. One other cool thing is to create a line space. So basically you say from 1 to 10, I need 5 numbers with the equal distance. And then you get this array. You can also create arrays from your own lists. So for example, if you have a list defined as this, you can just say np array this list, and then you get A as your list. Okay.
Sorry, Stefan. NP, is this a specially defined class?
No, this is Numpy. We import it as NP. So we just rename it as NP. This is Numpy.
Oh, okay.
You can
So
just call it.
Can use any name.
You can say Numpy. All right. But as I said, because people want to be faster, you just say NP. Yeah. And this is a standard abbreviation actually. So if you just Google something, you can say NP this problem, then you will get the solutions with Numpy. Yeah. So now you have this array, and then you have lots of methods that you can apply to this array. So you could see the list of all the methods here in the NumPy documentation. There are many of them, but I just introduced you the most practical ones. So first of all, you can just print an array. So this is like, you get this array. You can have the sum of all the elements. So if you have everything, you will get 5. You can get mean or standard deviation of this array. So this is the average of these numbers, and this is the standard deviation of numbers. You can have the cumulative sum. So basically 0 and half would be half. And then adding 1 would be 1.5, adding another 1.5 would be 3, and adding 2 would be 5. So you have a cumulative sum. You could have the same as cumulative product, which is like just because the first one is 0, everything is 0 at the end. But otherwise, you could see that they are multiplied together at the end. You can get the shape of this array, and then when you want shape, it shows you it is 5 by 1, and oh, sorry. So if the shape is 5, comma nothing, so it means that you have just an array of 5, but you can reshape it to other things. So you can reshape it to like having 5 columns and 5 rows and 1 column. So this is a way to reshape it to 5, 1. You get this, basically. Cleaner would be this. Yep. You get this, and you can also transpose it. So when you have something, you can just transpose it to other way around. And also you can get the maximum or minimum of the array. So you could get the maximum, which is like the 2 here, and you can get the argmax, which is like the number of the so the index of this maximum value. This value is 2 here, which is the fourth argument here, and that's why you get 4 as argmax here. You have the same for minimum and argmin. So standard. So if you have higher dimensional arrays, you have basically the same. So you can have like a 2 row array as I defined here, 1, 2, 3, 4, 5, 6 in 2 rows. And when you apply these methods that I showed you, you just need to say which axis you want to have. So if you want to have, for example, if you want to sum them, if you just say sum, it will be the sum of everything, which is 21 now. But if you say I want to have the sum in axis 0, then you get for each column you get a sum. So this is 5 is the sum of 1 and 4, 2 and 5 is 7, and then 3 and 6 is 9. If you do it in axis 1, then you will have you will do it by row. So the first row would be 6, and the second row would be 15. Okay, clear?
Professor, sorry to interrupt, but there is a difference between your page and the document that you upload. It's in block 14 about the matrix.
14. I mean here.
23. So print MP dot zeros 2 and 3, but in my document it's 5 in the parentheses. Only 5.
I just changed it now. So like
Okay.
that's
Okay. So it's just the dimensions.
hopefully you will get it. If you after a while you can just reload it and you get this new version.
Okay.
Yeah. So
and what does the 2? Okay, 2 means 2 rows, 3 columns. Okay, thank you.
yeah. Okay, so if you have an array, you can apply some mathematical functions. So for example, you can just, so let's see first the list of all the mathematical functions available. So starting from trigonometric functions, it's sinus, cosinus, tangents, arcsinus, and so on, everything, hyperbolic functions, rounding. So you can get, for example, rounding is an important one. You get like you can round the numbers to 2 digits and so on. You can get the floor style and truncate them. You can do the production sum and cumulative productions and so on, exponential and logarithms, and many other functions are available that you can apply to an array. So for example, I have this array of this array that I just defined. Now I just want to apply the square root of this. Then you can see this is, so let me, so this is the main array and then the square root of it. So 1 would be 1, 2 would be 1.4, 3 would be 1.7, and so on. And it would be the same for all other functions that we just got them in this list here. Another important things you need to know is if you want to select some numbers. So for example, for your array, if you want to select everything in the second row, you can just say, I need the row. So they are starting from 0, just for information. So the 1 means the second row. So I want the second row and everything in the second row. So you get 4, 5, and 6. You can say, I need both rows, but the first column. And then you get 1 and 4, which is these two. You could, yeah.
What does the divided and n mean?
Now this is just for a print to just make sure it is like nicely printed here. So
It's a
that
new
n
line.
is a new line. When you have /n, it will print in a new line.
Okay.
Yeah, maybe also just one comment regarding the print statement. Whatever you write in the quotation marks doesn't matter for the function. So this is just for your personal documentation. You can basically write anything in between the quotation mark and it doesn't change the output. The only part of the function is the letter 1 after the comma. So the comma array, this is where Python actually applies the function.
If I don't have this print this thing in the beginning, I just print this, there would be this. But now I just want to make sure that you won't mix things. That's why I print first the comment and then the output.
So quotation marks are basically comments within.
Yeah, they're just comments that are printing.
And from my side, you can actually put another comma after the function and put some more comments in another quotes.
You mean here?
I mean after array, and then you can put another comma inside of the brackets and continue with the comment. No, I mean after the array.
Okay, and then?
And here another comma. Yeah, and here something another.
Yeah,
Okay.
would be this. But you can just have it in a new line or something like that. Would be this.
It might be helpful.
Yeah. Okay. So this selecting thing is very important, especially if you work with the huge matrices and you want to go into a specific cell and change the number or get the number and work with this number. So this selecting is very important there. Yeah. The other thing is the conditions. So you can convert your arrays to conditions. So you want to see how many of them are less than 3. You can just say 3, like the first line is 1, 2, 3. They are true, and the 4, 5, 6 is false. You can just sum them to get the yeah, forget it. Yeah, you get true false things. There is another way to do that is to use the where condition. So you can say where the array is less than 3, put 1, otherwise 0. And it would be this. And then here you can, if you want to count how many cells meet this condition, you can just sum them up to see the 3 having this condition and so on. Another thing is reshaping. I just touched it. So first, if you have like an so let me first print you. So you define an array of 1 to 15, 0 to 15, and you call it G. So this is the array, and the shape of this would be 15. So it's an array of 15. You have ways to reshape it. So for example, you can reshape this to have 5 to 3. So you have like 5 rows and 3 columns. You can just this. So it would be 1, 2, 1, 0, 1, 2, 3, 4, 5. And this is one way. So you can also, so if you want to have 3 by 5, you can just transpose it. But there's other ways to do that. So you can just say, yeah, this would be the same as if you have G reshape 3 and 5. It would be the same. Okay, there is a difference. I'm coming to that. So the way you reshape it depends on the order that you want. So for example, there's two ways to do that. This here. So if you have 1 to 8, if you say order with columns with C, then it will be 1, 2, 3, 4, 5, 6 in two ways in this way. If you call it with F, it will be in columns. It would be 1, 2, 3, 4, 5, 6, and 7, 8. So this is an argument that you need to pass if you want to have a proper reshape. So if you reshape this G that we have here from 0 to 14, if you reshape it with C and F, you can see the difference here. So it would be 0, 1, 2. It would be the other one would 0, 1, 2, 3, 4 in a column. So this is just a trick. And finally, I just want to.
Do you know what this F stands for? Because usually you have row and column. So it should be C and R.
I just show you NP reshape. Oh, if you go to the documentation, it's Fortran like.
Okay. Great.
Yeah. Yeah. So this is C. It's based on C, and the other based on Fortran. So this is the way. Okay. Yep. So one other ways to I won't call it regression. We will have a regression. We will cover regressions later, but what we can do here is we can fit a line or a line of a polynomial of a degree of something to a data that we have here. So for example, assume that we have this data here. So we have some X and some Y's, and this is like the way you can see them. So how I could create them, I just created them with some random noise. And I just created some X from 0 to 1. So I created 100 observation of 0 to 1 and just created the Y's based on this data generation process, which is like 3 plus 2 multiplied by X and some random errors. And that's why you can see this observations here. So
sorry, there was np.random.random. Yes, the first random is a command within Numpy, and the second is the name of your variable, or what?
Yeah.
Okay, so the second random could be chosen by us.
Yeah. So you can Numpy random offers you like lots of ways you can create random numbers. So like if you just Numpy random means this. So it returns random floats in half open intervals. So so it will give you some random numbers between 0 to 1. Okay. And
okay, this is the second random. Okay.
This is the second random,
okay,
exactly.
okay.
So if you want to have, for example,
it's 2 commands.
Exactly. If you want to random based on a gamma distribution, you can just say random gamma, and then based on the shape, it will give you a random. or you can have like a beta distribution, Dirichlet, whatever. So there's all the random generators number here.
Okay.
And you can have other ways of random. You can have random integers and so on.
Is there an example here somewhere?
So there is no example here, but I think if you click on any of them, it will show you some examples.
Oh.
So yeah. So random sample means it's a random flows on half interval this. Yeah, I will come back to this random thing in the homework because there we want to have some Monte Carlo simulations and we need some random numbers. I will go with details there. Okay, anyway, so we have this X and Y observations here, and just we want to fit a line into this. Okay, so one way to do that is to use polyfit.
One moment to make sure. Maybe everyone knows it, but maybe someone doesn't. With this linspace, we created 100 numbers from 0 to
1
to 99, something like that. So 100 numbers, and difference between each step is like
one basis point. Yeah.
Okay.
Yeah. So you can see the X and Y actually. So these are the X that we have, and you can see the Y's that we created. So for this X, we have this Y, for the other X, we have this, and so on. And then we can, this is the way, we will plot, we will tell you how to plot them later, but just see them here, what's the data. And then if I want to have a line fitted there, I can say I want a polyfit of X and Y with a degree of 1 here, because line is 1. So you can just say, I need this polyfit here. And this polyfit returns to you the intercept and the slope of this line. If you have a higher degree polynomial, you will get more numbers here based on this function, based on this formula that you have here. So you will get the coefficients for higher degrees. So if you have like X, if you want to have like a degree 2 polynomials, you will get a 3 kind of things. And then so I can show you later. And then I can create a line of Y hats. So based on this intercept that I have here and this slope that I have here, I can create a Y hat and see what is my fitted lines look like.
Can you explain this line here? Because I don't understand this.
So this
Y hat is,
so Y hat is this orange line that we want to have. So this is the fitted line here. So when we have a polyfit, so it gives us an array of 2. So the first one is the intercept. So sorry, so it's always the other way around. So so it starts from the highest order. So it's like the slope, and this is the intercept here. And then what we can do is to just have an intercept, which is the first argument, and adding to the X multiplied by the slope.
And why is the second, the highlighted thing is just the intercept? I don't.
This is the way.
First element.
Yeah, this is like
how to call the first element out of this array.
It's like the slope for a line is a slope actually, but so if this is the documentation, you can say that this is Px. So P0 is like the highest degree, and it goes down until the P0, which is like
even more basic. With this command, yeah, you just ask the code for the first element of this vector, and you give the full vector name in there. Yeah, and
yeah.
polyfit.
Yeah. Yeah, I could do it by having a number actually. So a variable and I can call this fitted, and then
Okay.
would be the same. Yeah. Then I just plot them together. So we could try it with degree 2. So what we need to do there is to have x multiplied by x multiplied by this would be a degree 2, but it's like very,
Yeah, but the second order of 0.
yeah,
Yeah.
exactly, and so on. So it's the important thing is that so the 0 is like the highest degree and so on. Yeah.
Professor,
Yeah.
what does it mean in block 62 plot x, y, and this point?
This point is like I just want to show it with dots. So that's why I say show it with dots. So plot it with dots. That's the way you tell it to Python. But the plot comment we'll cover it next week. Yeah. Then you basically can also so extrapolate. So if you have some x that are not in your range, so for example, you want to see what will be happening in here when x is 2. So what will be the y here? So you can just say the polyfit of degree 1 multiplied by the, so the x that you want, like 2, just yeah, multiplied by the slope plus the intercept will give you the expected value at 2, at x equal to 2. Okay, so this is all the important things about NumPy. But basically, if you want to, you can have like a full course on NumPy. There are millions of things about NumPy that we could cover. But here are just the most important things. And I hope you get your hands dirty enough with the example that I give you and more examples that you can see in the future. So working with NumPy is very crucial. Basically, I had one master student who did some machine learning stuff for his master thesis. He worked for KPMG and he worked everything with like just for loops and everything. I obviously gave him 1.0. It was very good for me, but by chance I saw his supervisors in a later event, and I was talking about this thesis, and then the supervisor told me that no, this is like very stupid way of coding. He never used any NumPy array. He never worked with the matrices, and everything was just for loop together. So this is how much important if you want to be like if you want to work as a professional. You need to know Python, NumPy, and you want to, you need to do things more professionally with matrices and the algebra behind that. Yeah, that's the reason we covered NumPy today. So now I would like to start with the homework that I posted here. So I have it already here. So it's about the Monte Carlo simulation. So first of all, can someone just very briefly explain what is a Monte Carlo? Don't be shy. Like I can also like.
Well, you basically just plot some random numbers and then watch the outcomes. So in the case of finance, you can, for example, simulate how returns develop over time in a time series, like what we are going to do in this one, and then see how the final distribution will look like.
Exactly. Very, very good. So basically, if you want to create history for the future, you need to do the Monte Carlo simulation. So, so for example, you have a portfolio at today and you want to see what will happen in the next 10 or 20 years based on simulated futures. So you can have like thousands of possible scenarios and just create all of them and then see in each of these cases or each of these worlds, what would be next 20 years look like. And this is what we are going to do today. So
may I just add?
Yeah, sure.
Philip said you can look at the distribution. Yeah, this is one way to use Monte Carlo, but honestly, the distribution, of course, has been programmed. Yeah, you ask the computer to do a normal distributed future. There were two main uses in finance. Yeah, one is option pricing. Yeah, you can instead of using the Black-Scholes formula, you can do a Monte Carlo simulation and simply calculate the expected payoff of an option in the simulation and then discount this to today. And you will find this is exactly the Black-Scholes price. Now, of course, if you have a closed form solution like the Black-Scholes formula, you don't need the simulation, but whenever you have complex options that don't have closed form solutions, you can easily resort to Monte Carlo simulation. And the second very big usage is, of course, risk analysis in banking. Whenever you do risk analysis of more complex kind of derivatives or contracts, you simulate a Monte Carlo simulation. You basically simulate how the interest rates, stock prices, exchange rates, and so forth evolve over time. Then you derive from every scenario how your derivative contract, for example, would change in value. And then you can calculate the value at risk. That is basically a kind of quantile of the distribution. And then you can say with 1% probability, I won't lose more than $100, for example. So risk managers in banks and option pricing experts that work with complex options are the, to my knowledge, the heaviest users of Monte Carlo simulations.
Exactly. Also, I saw for the company valuations, people also do Monte Carlo. So, for example, they have like a scenario for the number of inventories. So, for example, so they have a model there with some uncertainties. That's why they can run a Monte Carlo simulation in 10 years and see like what is the distribution in 10 years would look like, and what's like that's also one way I saw.
Yeah, if you think about how much well, working capital, of course, is a function of your sales, and then you basically model how big the debt line must be in order to cover your working capital needs with a certain probability. And then you have a model that basically randomly generates the inventory needs and therefore the financing needs of your operations.
Okay. Yeah, so this is on the importance of Monte Carlo for you finance students. So let's see what we want to have here. So I want a very simple Monte Carlo simulation here that given a portfolio at the time 0, which is today, based on some expected returns and expected volatility, and we want to see what will happen in 20 years on this simple portfolio. So I just
explain the imports.
So the imports
use more than Numpy.
This is not needed. So I just need matplotlib to plot something. So that's the only thing you need. But the plot functions are already defined down there, so people don't want to change it. But the main thing is NumPy. So basically,
what this inline means?
Here, like I will cover them next week. Don't worry. But so this specific command is there to have a better image embedded into the HTML here, into your Jupyter notebook. So that's like, there are standard things you don't need to take care of. You only need to know what is Numpy doing here. Okay.
Professor, why you write point py plot after matplotlib?
I use a specific library of matplotlib. This is like a huge project. I just need the pyplot version of that, and then I need to do some simple plottings. That's why I do this. But matplotlib is on our agenda in the 3rd week, so don't worry, we will cover them. Just accept this PLT stuff as given, and let's focus on NumPy. So we define 1,000 iterations. So basically, we need 1,000 simulations for 20 years with the expected returns of 7% and the volatility of 0.15. And the initial value of our investment would be also 1. So what we are doing, so this is basically your job to guess what we should do here. So first, we need to create a scenario of random returns. So that's why you need to have a normal distribution. If I can find. Yeah, so basically this NP random normal gives you, based on your expected value and your standard deviation, it gives you some random numbers. So this 1,000 means 1,000 random numbers. You can ask a shape of, for example, for us, we need 20 years and 1,000 iterations. So we need a shape of 21,000 somehow with this expected return and this expected volatility. So just don't want this to be solved. So you create these returns, and then you can yeah, you can see the returns themselves. I don't want to do it now, but you will do it. And then so for each of these 1,000 observations, you need to have a cumulative returns at the end. So how I would do that, I add returns to 1. So because, for example, if a return is 4% this year, I would want to have 1.04 because I just want to multiply all of them together for the 20th year. Okay. And then I would initialize all the returns with the initial portfolio value that I have. And the simulated portfolio would be a cumulative returns of all these returns in the last 20 years, okay? So for each of these 1,000 iterations. The important thing here is for you to see what kind of axis you need to put here. So you need to cumulate based on 1,000 scenarios for 20 years. So the accumulation should be on 20 years, not on 1,000 dimensions. So this is one thing you need to do. And then you need to show your simulations, okay? And then I can show you my own simulations. So there are already 2 people doing that, but yeah. So this is what I got from my own code. So all started with the initial value of 1. After 20 years, you could see some Warren Buffett's here, purely by chance. And but you can see most of the returns, like they are around here. So what I'm interested next is to look at the final stage and get the summary statistic of the final stage of all these 1,000 portfolios. Okay. This is basically the code you need to run. So first of all, so how many observations we have should be 1,000. What is the mean of all this 1,000 portfolio? I think there's someone who answered, so let's judge him or her. Okay, so we got he got 1,000. Who is he? Flip. Okay. So we have 1,000. The average of these values for him was 3.89. And then there is a theoretical return. What would be theoretical return? So if we have like an expected return of 7%, you could just cumulative 7% over 20 years and multiply it by your initial value. And then this should be your theoretical return. And these two numbers should be very similar. And I will tell you in a moment why these two are not similar here, because there's a problem in my code that you need to solve it. And otherwise, theoretically, these two numbers should be very similar. Okay. So, and then you get the expected the standard deviation and maximum and minimum. So the minimum of these things would be 23.23. So these losers lost 75% of initial values after 20 years. But this is the worst case scenario, and the best case scenario is like you multiply your initial investment by 21. This is all the hypothetical things that could happen in the next 20 years over this simple portfolio. So at the end, I just posted 3 questions. You also need to discuss it in the Piazza in the following week. So, so first one we already covered somehow. What are the other use cases of the Monte Carlo in finance? The second thing is, the issue that I have in my code. So you need to solve this and you need to spot this. I have a very stupid mistake there. So you need to easily find this. And then third is, will the market behave according to normal distribution? I also like to see your discussion there. So we assumed a random normal distribution of expected return and volatility and expected volatility, but I don't know if the market will behave like this in the future. So this is like I'm waiting for your suggestion. What would be the better distribution that we can use here? Okay.
Yeah.
So
the more advanced students are invited to look into any kind of option pricing book. The famous book of Hull, of course, explains what the expected value of a stock after 20 years is. And it is not just taking the mean value and transposing by 20. And any option pricing book. And the reason is why is because we have here wrong emotion with volatility, and volatility chain has an impact on the mean of the distribution. But that's for you to find out either by experiment or by looking it up into the textbook.
Yeah. You're more than welcome to change the code and post your own solutions. Yeah, let's see. Okay, so is there any other questions? I would like to start with pandas, but we have just 5 minutes. So yeah, probably.
Maybe an organizational question. Will we start at 10:15 or at 10? Because today we started a bit later.
Yeah, my plan to start at 10:15 and finish it right at time. So let's keep it as it is. So 10:15, or in Thursday we will have at 2, I guess 2:15 would be. Yeah, so start at 15 and then let's have the class for 1.5 hours, not more. But let's.
Okay.
Also for the next for the next session, we'll start. So as you guys are more advanced in Python now than last week, hopefully. So in the next sessions, we will have less focus on coding. So for example, here it was like mainly coding today. So the coding parts could be done by you by just reading the documentations, and I just give you some hints. So in the future, we will have less kind of these today's sessions that we purely code. So we will have more theoretical aspects of how to work with data, how to collect data, and so on. And yeah, that's also like a head up for Thursday. Okay, question? Yeah.
So are we going to
wait?
Sorry. So are we going to have this session at the Thursday also in class, or?
So for Thursday, you have the option to register for the in class, but the class would be in Dubai in the first floor of House of Finance, and you just need to visit my booking, and 3 days before the Thursday, so I guess tomorrow, it will be opened, and then you can just register if you want to attend the class. Other questions?
Yeah, let's try.
Okay. Okay, so apparently there's like no other questions left. So thank you everyone for your attention today, and hope to see you all Thursday. Okay.
Okay.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.
Goodbye.
Goodbye.